Greetings, everybody, wherever you may be, and welcome once again to Kourou, the home of Ariane, for this afternoon's live broadcast of Arianespace flight number 164. A big event and a major milestone in the Ariane program for this mission. You'll be watching the long-awaited return to flight status of the Ariane 5 ECA, including reports of the launcher and satellite campaigns, interviews with customers and other key players, and, of course, liftoff. All that is just ahead. Commentary in French tonight will be handled by Thierry Bouvard and Muriel Bailly. In English, Joshua Jample with Alex Maiden B2. And for our Spanish listeners, Julio Montreal and Matías Balbuena. And you can follow us on the website at arianespace.com. We are proceeding normally, as you can see. We're on time and on target from Kourou. Hello to Alex Maiden B2 first, a project manager from Arianespace. Good evening.
Thank you, Josh. Hello, everybody. Special greetings to all our customers and partners wherever they are in the world.
Alex's voice is familiar to those of you who are familiar with the Ariane broadcast. You've done the broadcast many times. The Ariane 5 ECA coming back to service after a little over 2 years tonight. And we're going to go to some opening words for the broadcast to Jean-Yves Le Gall. We're about to finish preparations for Flight 164, and tomorrow, if all goes as expected, the launcher will be moved out to the launch zone. The Ariane 5 ECA will be flying again. You'll remember that the December 2002 Ariane 5 ECA launch was not successful. Since then, a considerable amount of work has been done. In the first place, by the member states of the European Space Agency, which found the funding to finance this return to flight, which was not so simple after December of 2002. Some of you recall there were many doubts about its ever happening, but nonetheless, the member states of the European Space Agency managed it, and I think we owe them much thanks. Thanks also to the engineers and technicians who first worked on the causes of the December 2002 failure and corrected them, and then afterward carried out an exhaustive review of all the other parts of the launcher. A huge amount of work has been accomplished throughout these 26 months. I'd also like to take a moment to mention Arianespace's customers, who have continued to place their trust in us over this period. We currently have an order book of 40 satellites to be put in orbit, which is the biggest order book in the industry. Of these 40 contracts, more than half were signed after December 2002. Tonight, then, I wish and I hope that all this work will bear fruit, and in just about 10 minutes, the Ariane 5 ECA will accomplish its mission perfectly.
Ariane 5 ECA.
In exactly 10 minutes and 57 seconds, as you can see, we are going to begin a series of visits, some interviews with key players in the European space industry responsible for bringing the ECA back tonight. First, Antonio Fabrizi from ESA. Mr. Fabrizi, can you tell us about ESA's role in bringing the Ariane 5 ECA back to service?
Generally, the role of ESA is primarily to interpret the political will of the ESA member states and to transform it into an action, into a result. After the 517 flight, it took a few months, 5 months, to go through the analysis of the problems, to develop a plan for the return to flight, and to convene the ministers of the ESA member states in May 2003. Now, this was the first milestone that we had in this process of return to flight. Was the political one. It was a very important one because it was the time when the ESA member states confirmed in a clear and strong way their intention to keep the autonomous access to space for Europe. So the role of ESA has been to make of these entities a team looking ahead to this return to flight. And another important role that has been played by ESA in these years has been to chair the qualification review. The closing of this review is the final milestones that we achieve in these days before we give the final green light for the return to flight.
We are now back to the launch pad for the first Ariane launch of year 2005, the 21st Ariane 5 launch and the 165th Ariane launch.
We're launching in the daylight today, which is rather unusual. We'll get back to that. But before, Philippe Roland was the mission director for a look at the mission.
We shall then launch Flight 164 this late afternoon. The particular aspect of this launch is that we have the second-of-a-kind launcher being composed of a lower cryogenic stage and an upper cryogenic stage. This is what we call here the heavy rocket. The performance of this so-called heavy rocket will allow the delivery on orbit of XTAR satellite, which will be separated and operated by the Spanish government for its military needs over the region. Under XTAR, the lower payload is composed of a dummy spacecraft equipped with many sensors that will allow the monitoring of the launch vehicle's flight environment, like the acoustic noise under the fairing or the satellite's shock environment. And at last, the SLOSHSAT satellite developed under ESA's responsibility, which will allow a better simulation of the fluid's dynamical behavior on orbit, on board a launch vehicle or a satellite. The launch window shall start at 4:49 p.m. and close at 6:10 p.m. Kourou time. After a geostationary transfer orbit, XTAR satellite will reach its final orbit at 36,000 kilometers over Spain.
The launcher stands 57 meters tall. It's in two parts. They call them composites. The lower composite is the cryogenic core stage and the boosters. And the upper composite is the upper stage, the new upper stage this evening, and the satellites. Looking into the Flight Directorate, the Arianespace Flight Directorate, which is where the top management sits.
À tous de l'EDO, attention pour H0-7 minutes.
The DDO is going to call out the 7-minute mark, and we'll be into the synchronized sequence.
Top H0-7 minutes.
We are into the synchronized sequence. This is the final portion of the final countdown. Now what's happening?
Now the synchronized sequence is conducted by the two main computers for fluids and electrical systems. So we shall undertake the last operations before the flight.
We're going to go over first to the COEL, Pierre-François Beneteau, for a look at the launch campaign.
We are now reaching the end of the L521 launch campaign. It was a hard campaign for the whole launch team, as well as the technical team involved in production and development activities, since the operation started in 2004, which represents 120 days of operations and 4,000 operational tasks, for a launch campaign that spread over 2004 until November and restarted in January this year. Among the main activities of this specific launch campaign, we had two wet dress rehearsals, RSLs, during which the launcher was put in flight configuration and two synchronized sequences were performed. The first RSL carried out evaluation of qualification requirements, and the second one was conducted up to engine ignition. Integration of the satellites on the launch vehicle took place in January 2005, and we are now ready for liftoff.
The synchronized sequence, as we started to say, is done by two computers up in the CDL, which is this shot here, which is where Mr. Beneteau's crew is. Now they're checking out how many, hundreds of the final operations, I imagine.
Yes, about that amount of operations, including the final loading of the cryogenic stages, the end of the topping up sequence, and the pressurization of the cryogenic tanks of both upper and lower cryogenic stages. Also, electrical systems are put into flight configuration.
All right, more on that, but for right now, over to the latest news from Arianespace. 2004 went out with great fanfare as Ariane successfully injected 7 payloads into sun-synchronous orbit. The December 18th launch delivered a military satellite, Helios 2A, along with a record 6 auxiliary payloads. Arianespace now has a 100% success rate with its 25 military missions. At the annual New Year's press conference in January, Arianespace Chief Executive Jean-Yves Le Gall told the international press that the company has entered 2005, its 25th anniversary year, in sound financial shape and is looking forward to a busy 12 months. After Flight 164, Arianespace plans 5 other Ariane 5 missions, as well as 3 commercial Soyuz launches from Baikonur. Arianespace announced signing of 5 new payloads last month. The first 2, Skynet 5A and 5B, are military communications satellites for the UK Defence Ministry. CORO is a space observatory that will look for new planets. It'll be orbited next year from Baikonur on the first flight of the new Soyuz vehicle that will later come to Kourou. Soyuz will also launch 2 Pléiades satellites for CNES in 2008 and 2009. Weighing about 1 ton each, they will perform both civil and military missions. The city of Bremen, which sponsors tonight's launch, is the latest European town to do so. The German city followed tradition by planting a tree in front of the Jupiter Mission Control Building here at Europe Spaceport. And Europe Spaceport ranges over 750 square kilometers here in French Guiana. That's about the size of Singapore. A lot of activity on the launch base with different operations, as you can see on the left, which is a summary of all the different range services.
This panel is a summary of all the preparation status of all the technical systems and resources involved in the final chronology, but also flight. This includes, of course, the launch vehicle and spacecrafts, as well as the launch-based telecommunication systems, ground stations, meteorological station, and the launch pad installations.
All the information from the different regions, the different divisions, I should say, come in here to the Jupiter Mission Control Building, which is actually the nerve center of the space base, and the DDO, Rubardier, whom you saw, and whose voice you heard, call out some of the milestones, makes the final go or no-go based on those informations. These shots were taken yesterday. This is the Ariane 5 coming out of the BAF, the final assembly building, rolling on a rail track.
Yeah, this operation takes about 6 hours, and this about 4 kilometers to roll between the BAF building and the launch pad. During all this transfer, there is a permanent monitoring of the satellites that is possible through a fiber optical link.
For the satellite teams?
For the satellite teams which are in their dedicated buildings.
That must be a big advantage for them to be able to be in contact with.
That is a big advantage, and they can monitor the spacecraft all throughout the operations, even from the BAF during the transfer and then again on the launch pad.
This is a split screen shot of the feeder arms, the propellant arms feeding the upper stage, the cryogenic fluid. Those arms, when we have liftoff, before we have liftoff, will retract, and that's what you'll see before the engines are ignited. You'll hear the DDO in a minute calling out the 1 minute mark.
De DDO. Attention pour H0 moins 1 minute. Rouge ensemble de lancement. Rouge ensemble de lancement.
And at the 1 minute mark, Pierre Bardier has just called out, you can see we're red up in the corner, a red on the status panels for the
ground installations.
Ground installation, that's ensemble de lancement as well.
Ensemble de lancement.
À tous les DDO, nous avons un rouge ensemble de lancement.
We have
Et le décompte est arrêté.
We have a red on the ground stations, and the countdown has been halted at minus 59 seconds. Now, we have 2 reds, as you can see, one on the top, authorization to fly.
Launch is not authorized, and the ground installation of the launch pad have a red. So I think we'll know more after the DDO. We'll get some more information on that red.
This is what we mentioned, the range operations, ground installations, weather, telecoms, safety, all the things that you mentioned, send their information here, and from some ground installation somewhere, some data came in, which apparently was not...
This may be the case. This can be a wrong status of a valve or a failure of a computer, for instance.
We're waiting for the authorization to start the countdown again. As soon as we have something on that, we will of course let you know. Now this is a shot of the launch pad. There, it looks like it's raining out there. The when after the rollout, when Ariane makes her way, now we're back at 16 minutes up there, on the red on the corner.
Yeah, so we shall resume the automatic sequence at minus 16 minutes.
So this is what we were saying before. During the synchronized sequence, we have a very crowded schedule. But if we take too long performing an operation, or if there's some kind of a red, we have to start over at 7 minutes, or at tonight 16 minutes.
Yeah, so the first operations to undertake are to put the whole systems in safe configuration. So, and then to resume all operations at the starting of the synchronized sequence, in that case, the earlier operations at minus 16 minutes, and fix the problem before all the sequence can be resumed.
So when you have a hold like this, I imagine that you've seen holds like this before.
Many times, many times.
So what's happening when we see the people on the phone?
Well, in that case, this comes from the launch pad. So if it's from the ground side, maybe a computer, for instance, then people have to fix the problem first to understand why we have had this red. In the meantime, all the people in charge of the fluids operations put the system back into safe configuration and monitor the topping up sequence of the tanks, while the other people just fix the problem and try to find a solution to resume operations.
For instance, what's going on up at the CDL where we saw Pierre-François Beneteau?
So I imagine that the present time at the CDL, there are some people concerned with the problem. So it may come from the computer system or from the ground installation itself. So it might be one of the valves or pressure sensors or equipment of that kind that may have had a failure. So we have to first assess the I would say the gravity of the failure, and then to resume the operations.
See if we can fix it in 5 minutes or in still keep to our launch window.
Okay, so we have had some information according to which we should have read during 20 minutes, 15-20 minutes. So I think they are in the way of fixing the problem.
So as you said, the ground crews are looking at the problem and they've seen that it can be fixed in a certain finite period of time. We can fix it and stick to the launch window.
Yeah.
Still get the mission.
Yes, if we're well within the launch window opening, then we can still launch tonight.
And the launch window is an hour and 20 minutes?
1 hour, 21 minutes.
Which is that a normal launch window, a long launch window?
Well, the launch window is depending on the satellites, constraints while after having been released by the launch vehicle. So tonight, it's XTAR satellite is allowed to have a real constraint on the launch window. So it might be more restrictive for a double launch, for which two satellites have to have their constraints mixed together. But the minimum launch window is always 45 minutes.
45 minutes. But all the constraints of launch windows are decided by the passenger, because Ariane can fly at any time, right?
Yes, you're right. Apart that we have to make a compromise between the launch vehicle, the satellite's constraints, and also our operational team's constraints. Meaning that you have to start the operations at a certain time that is typically minus 9 hours. So
you don't want to start at 3 in the morning if...
well, we can do that. We have already done that. But if we can avoid it, of course, and if this is compatible with the satellite's constraints, of course, this is much better.
All right, we are still holding at 16 minutes. We're red, as you can see in the top right. And on the lower left, you can see Ensemble de Lancement, which is the ground stations. We have a red on the status panels which means we are waiting for a problem to be solved. We may be going to keep you entertained in a moment to some short films. We may be looking at the first film on the newest weather station, which was built here a couple of years ago, I think. But before we go there, we're not going to the weather. We're going to a short film on the Ariane 5 launch table. That'll be coming up in just a few short seconds. And while you're watching that, we may have some more information when we come back to you. The launch table film coming up presently. Here's a riddle for you. What looks like a boat, but runs on rails? The answer, the Ariane 5 launch table. This second Ariane 5 launch table was first used back in November of 2000. That was for Flight 135. At that time, the launcher for 135 was one of 4 launcher campaigns going on here at the CSG at once. That was a first. So you see, having the second launch table makes a big difference. It means we can work on 2 Ariane 5 campaigns at the same time. With us is Martin Unal, who's Ariane's launch operations deputy, and Martin's going to tell us more. Martin, what's the role of the launch table?
The role of the Ariane 5 launch table is to provide the launcher with everything it needs to be ready for launch. It provides propellant for the main stages, electric power for all on-board electronics, and diverse tracking, telemetry and command which let us carry out all operations. Let's go inside and have a look. In this part of the Ariane 5 launch table, we receive the customer base, which let them monitor their satellites during launch operations. The satellites are pulled through this trapdoor in the floor by a crane, and we secure them on the ceiling with heavy springs which absorb the vibrations at liftoff. From here, customers can connect to their satellites via dedicated links installed by Arianespace on board the launcher. Fiber optic cables can also connect them to their control office in S5 or S1, so they can follow the status of their satellites in real time and make any necessary decisions. A launch table is a real factory. It is as complex as the launch vehicle itself. It must provide everything necessary to the launcher so it can be autonomous. We use it to save the launcher's resources before liftoff, so it can leave the pad with a maximum of fuel and energy on board. The table duplicates a large part of the functions found on the launcher, but must be more resistant to be able to work for the next launch. The launcher, on the other hand, leaves the pad and disappears. You can say that one is almost the mirror image of the other, because the table's role is to provide assistance to all the launcher's needs. Ground crews have a lot to do and can sometimes work twice as much as the launch crews, because they work in the preparation before integration of the launcher, then after the launch as well, to revalidate all installations. We recheck everything systematically each time, and that takes a lot of work. Having 2 launch tables for Ariane 5 is a tremendous advantage for us in terms of flexibility. 2 tables let us prepare 1 launcher while we have another one on the pad. With 2 tables, we can double our annual launch rhythm. For customers, this means more flexibility and availability.
The main differences between the Ariane 4 and Ariane 5 launch tables come from the different philosophies adopted in their conception. On Ariane 4, we wanted a minimum of mobile installations because it was so complex. Ariane 5, on the other hand, uses solid boosters which are somewhat hazardous, so the computer bays had to be fixed to springs to protect them from vibrations. We also opted for a mobile infrastructure which protects everything. This also gives us a big advantage in terms of flexibility, since the only connections you as a customer need to make are those when you arrive in the integration zones. None is needed for installation between the table and the launcher. With Ariane 4, once the launcher's on the table and has been checked out, it's already been in the launch zone 2 weeks. The transfer of Ariane 5 is done in 1 day.
Just jump in.
All right, back still holding at 16 minutes. You can see we've got 2 reds now. There's one for XTAR. What could that mean?
Well, that could mean only mean that the preparation status of the satellite that was okay. At the beginning of the last synchronous sequence, they may have to.
Le rouge XTAR montre simplement que le satellite est repassé en énergie externe.
Right, the DDO just said.
Yes, so the satellite had to switch on to ground power supply. So
just the normal.
Yes, so he has to switch over to onboard supply again.
So we'll probably very shortly see that red disappear on the XTAR.
Yes.
But for the moment, we're still stuck with our original problem. For the moment, on the ground.
On the ground installations.
We're going to go shortly to another film while we're waiting on the weather station called Romuald. Something like that. But before we do, just to recap, we ran into a red at just about 1 minute. It was about 59 seconds, minus 59 seconds. The DDO called out a red. And the COEL, Mr. Beneteau, whom we saw earlier, and his team of 100 or 200 have been looking at these parameters. Something outside of the normal was found, and they've done their analysis. And they must now put the launcher back into launch configuration. Which means what exactly?
Which means that you are ready to start the synchronous sequence all over again. And for this, you have to monitor especially the cryogenic sequence of topping up the LOX and LH2 inside the cryogenic tanks.
So the automatic sequence, as soon as they fix it, will be starting up again. We're going to go to our film on the weather station, and we'll be back.
Romuald is the acronym for the new weather radar of the CSG for local and remote weather observation. The station is located at the Montagne des Pères. The radar's range is of 400 kilometers. It is extremely accurate. If we want to scan at a shorter distance, say 50 kilometers, we can get information every 250 meters in the form of 1 pixel every 250 meters. Furthermore, it is automatically calibrated, which guarantees stability over a period of time. We have 2 main operating modes. One is horizontal, whereby we scan 360 degrees at a fairly low elevation angle. This provides us with an overhead view, giving us the position and subsequent displacement of the cloud cover. This is what we call a horizontal scanning mode. The radar can also be operated to scan volume. It rotates at different angles, scanning space. Then the workstation processes the data received, providing a 3-dimensional picture. Here, for instance, you see a view from above, the cloud's position and shift, and up here and on the side we get a lateral view of the clouds. The cloud's thickness reaching up to 5 or even 7 kilometers. As far as the launch is concerned, this radar is particularly helpful because of the faster rotation of its antenna. This provides us three-dimensional information every 5 minutes, as compared with every 15 minutes with the former system called Rodin. One of the meteorological criteria to get a go for launch depends on the vertical development of the cloud cover around the launch pad, something that can change very quickly here in French Guiana. Receiving 3D info every 5 minutes allows for more accurate transmission of go, no-go criteria, particularly the switch to go status.
Back at Kourou with our two reds, we're going to go to another film on the Devil's Islands, which I think you'll enjoy. But before we do that, as you can see, there's a red on the satellite too. And as Alex was saying, any red in the count, any stop, any hold in the countdown, can throw a red on the satellite. If, as you said, it was already on internal power, it might come back to the ground power supply, which means it's not ready for flight.
Yep.
That's what you were saying before. The satellite manager can also put a red on the satellite if some final checks or operations are not completed. Now we've got our ensemble de lancement back to green, but we're still red on the satellite. So that's just a matter of time, I imagine.
Yes, the satellite has to redo its operations before it can switch on to onboard the power supply again. So this is a matter of seconds or minutes, I guess.
Because it looks like it's taking longer for the satellite than for the ground systems.
The satellite switch over to ground during the red of the launch pad red, and then now it will be back to onboard power.
So that's what we're waiting for. We're waiting for the XTAR people to give the okay that they're back and flight ready. The launch base has apparently found and solved their problem.
They have apparently found and solved the problem. As far as we heard, there was some problem of pressure measurements coming from the launcher and being made by the ground computers. So they apparently have solved the problem, and then we should be ready to resume the countdown.
Hundreds of operations in a very complex launch vehicle like the Ariane 5, of course, to be checked. And Arianespace wanting to make sure that everything is letter perfect before giving the okay to fly, as you can well imagine. The DDO will momentarily call out the resumption of the countdown. That's what we're waiting for. And we'll pick up at minus 16 minutes again.
Yes, we'll be back to 16 minutes to resume the cryogenic sequence for the final loading of the LOX tanks and LH2 tanks.
We're waiting for our third film. We're not going to the... We are still waiting for the DDO to resume the countdown. We can see, you don't have it on your screen. You don't have it on your screen, but we can see it on the, here in Mission Control, the both reds.
We have the launch base, the launch pad red again.
That's coming and going.
So maybe it's due to the return to configuration of the ground installations. We'll know more, I think, in a few minutes.
And while we're waiting, we're going to go to our next film, which will be on the final assembly building. You saw Ariane 5 roll out of the final assembly building. The shots from rollout, which were taken 24 hours ago. This building is, I think, the tallest on the launch base, 120 meters tall, I believe. That's where the final assembly and the mating of the satellites are carried out. There's a special section for the satellites, which was not the case for the Ariane 4.
Yes, you're right. For Ariane 4, in fact, the buff building was made by the big tower and big gantry, inside which we had the mating of the upper part with the fairing and the satellites on the top of the launcher. Here it's a buff building, but we have close to belonging to the same building, we have a part for a clean room for the preparation of the satellites in combined operations. that is encapsulation and mating the satellites inside the cylinder, for instance, on top of the cylinder and inside the fairing.
Which is again a big advantage for the customers because their satellites are very close to everything. They have almost a one-stop shop here.
Yes, the operations have been optimized from what we used to do on Ariane 4, that's for sure.
We'll be going momentarily to the film on the final assembly building, which will be a film that will last about 3 minutes, I'm told.
The main activities are devoted to filling the EPC, the main cryogenic stage, with liquid hydrogen and liquid oxygen. Then we move to final countdown and the liftoff sequence.
We're coming down to the wire now. Liftoff is just moments away. Well, while you were watching that film, you see we we switched back over to green on the XTAR status panel. So everything is ready to go as far as our customer is concerned. However, we still, as you see, have a red on the ensemble de lancement, which is the ground installations.
So as far as we know, as we've been informed, we have some measurements which are not the ones that were expected coming from the launcher. So it might be the ground computer or the sensors themselves. So people are still investigating before releasing a green.
So it's decision time. People are still on the phones. I guess Evry is on the phone with Kourou, and the satellite people are talking to their headquarters, and a lot of
yes, we have a permanent link with all our offices in the world. It's Singapore, Tokyo, Washington, D.C., and of course all our customers are with us tonight.
And the flight directorate, which you saw earlier, the Arianespace top management, those people are in discussions with the COEL and a special COEL, because I'm told that the original COEL does not really concern himself with this incident, or is that old information? There's a special COEL who discusses this with the flight directorate. In just about 10 seconds, we're going to go to a film in 3 parts about pollution and the environment, which of course is a big issue here in French Guiana. I think you'll like it. It's you're going to see some birds and some fish and some water. That's in 10 seconds coming up on the pollution and the environment here in French Guiana. And then we'll be back, hopefully, with some more information. So you see very particular and rigorous measures, checking the water systems and the quality of the air at the space base. Anything concerning with transportation and stocking and filling of the materials necessary for propulsion for the Ariane 5 and for the satellites are under high security. And they have special trucks to transport them. We're still on the red, as you can see, and we're still holding at 16 minutes. They have qualified drivers. They have speeds that they cannot exceed, and they're escorted. And the dangerous, the hazardous materials arrive at the port of Maracaibo, which is where?
The port of Maracaibo is right 1 kilometer far from the CSG, the Space Center. And this harbor has been made and on the maybe not very far from the sea, from the opening of the river,
from the Kourou River into the Atlantic.
To the Atlantic.
So, of course, stocking of these materials also under high security. It's done in an independent zone and limited access, of course, as you can imagine. So you see the CSG every year carries out tests on the impact of Ariane 5 launches on the air and the water. They measure the hydrochloric acid concentration, not only in Kourou, but up in Sinnamary. Some of you have been up there. And the technical center, where we are here. One interesting point is they also look at the water quality in the
at the ELA-3 launch base. Now, you haven't seen it yet, but when Ariane lifts off, there's I don't know how many tons of water that come in to not only cool off, as far as I understand, the base, but also to dampen the sound. Is that right?
It's to dampen the acoustic effect of the thrust of the main thrust delivered by the solids, and also to cool down, but also to cool down the launch table right after the launch, because it's of course a hot part of the table right under the solids.
And that you'll see when we get to liftoff, and you'll see the water come pouring in before Ariane leaves the pad. I think the water starts coming in. Is that right?
It's a few seconds before.
So we're going to go to our film now. All right, you can see we are still stuck at 16 minutes, and with our ground station red. Do you have some news for us?
Yes, we do have some news from the launch pad stating that we have almost finished the investigations on the pressure transducer, and we should come back to a green in a few minutes, even not if seconds. These investigations may have been. May have taken a shortest time, but it's not the problem is not always to fix the problem itself, but to assess the consequences of fixing the problem. You can always bypass pressure transducer measurements, but you have to assess what will happen if you do so, and this is why the analysis of the problem may take some time before the problem is fixed.
So, as you can see, we're still waiting for the final go to start the countdown again from the Launch Operations Center, where the technicians and engineers are trying to fix the anomaly, as they call it. If the anomaly, of course, is fixed and we're still in the launch window, and we still are, the countdown will be reset at
minus 16
minutes. Now, the 16 minutes is the time needed to put the launcher back in optimal flight conditions.
We need 16 minutes to complete the final loading of the cryogenic tanks and make all the last verifications of the electrical and fluid systems of the launch vehicle.
Well, all that is underway, and as soon as we get the OK to launch, we will, of course, start the countdown again. There's another actor in this business with the COL and the flight directorate, and he's called the CPAP, which is the Ariane Production Project Manager. He's the technical authority.
The CPAP is the technical authority, is assisting the COL in everything that concerns the production of the launch vehicle. Now we're back to green for the launch pad. So the decision has been made to resume the operations for synchronized sequence.
And you'll hear the DDO, I imagine, in a moment, Pierre Bardier, calling out the resumption of the countdown at minus 16 minutes. For the present, we are green, but we're not moving. Clock is not ticking. So apparently, the flight directorate making the decision to go. The technical crews at the Launch Operations Center have fixed the problem.
Batteuse de l'EDO, préparez-vous pour une reprise imminente du décompte.
An imminent restarting, resumption of the countdown is the word. So in a moment we should be off again at minus 16 minutes, counting down to liftoff on this first launch of the year, Ariane 5, the return to service of the Ariane 5 ECA. 8.3 tons passengers, XTAR, and MAQSAT, and SLOSHSAT.
8.3 tons include the satellites, but not only the satellites, also the upper structures that go with along with the satellites. This is not the 10 tons that was that was called for the first ECA, but this qualification flight has this flight configuration tonight, and of course in the coming launches we shall improve the performance of this launcher.
You're looking at the RCUAs. This is your job. This is the fellow on the right. You'll be hearing from him later. Michael Calleri.
Michael Calleri is responsible for the payloads, the interface with the
customer interface. That's what you do normally when you're not broadcasting.
Yes.
We'll be hearing from Michael a little later in the broadcast. We spoke with him earlier in the week, and he gave us a look at the satellite campaigns, both of them. Still waiting for resumption of the countdown, which the DDO has said coming up. And we can be underway on this bringing to fruition of an enormous amount of efforts made by the European Space Agency member states, which first of all found the money to move ahead on the Ariane 5 ECA after December 2002, flight number 517. This return to flight, as Jean-Yves Le Gall mentioned in his opening statement, had there were two parts to it. First of all, they had to look at the Vulcain. There was a propulsion problem with the engine. They had to fix that and then make it ready for flight. And then also they had to carry out an exhaustive review of the launcher and all the other parts of the launch vehicle, which actually, as Jean-Yves Le Gall said, called for as much work as the work on the Vulcain 2. And there was there were new elements to be tested and to before we could get the green light. So it's a fine example of European industrial cooperation, I think, between ESA and CNES and DLA and the Ariane people working together. Customers, of course, remain faithful during this period, as Jean-Yves Le Gall said, with we have, what, 40 satellites?
40 satellite launch and 20 contracts that were signed since the December 2002 maiden flight for Ariane 5 ECA.
Which is half of them. This success also allowed for continuation of the Ariane 5 because we ordered the PA batch of...
We ordered a batch of 30 launchers to the prime contractor for launch vehicle manufacturing, which is EADS, Space Transportation. And with this batch, of course, we shall be able to launch our customers in a timely manner.
This batch is 30 Arianes. How many ECAs and how many?
Among these 30 launchers, the majority is, of course, ECAs. We have some flights which will be dedicated to the ATV.
There's a lot of those.
Spacecraft. And there are we have nine ATVs to launch.
And the ATV,
contract.
The ATV is going to the International Space Station. Is that
the ATV is going to the International Space Station, delivering logistics.
ATV is a transfer vehicle, right?
It's automated transfer vehicle.
To transfer astronauts?
No, it's not a manned vehicle. It's only logistics cargo vehicle to go to the space station. And in return, to get all the wastes coming from the station, and then it'll burn in the upper atmosphere.
Stocking and destocking, of course. Space station is always a concern. We won't say a problem. We are green at minus 16 minutes, but the clock is not ticking. So we're waiting for that to happen. The launch base, the launch base at Kourou we mentioned is about an 18-kilometer strip along the beach here, along the coast in French Guiana. A launch base, we could say a word or two about what a launch base is exactly, because it's a rather complex group of facilities, making it possible for mainly three things, I would say. Preparing a launcher and payloads. You correct me if I'm wrong. Performing launcher operations.
À tous de Léo, tenez-vous prêts pour une reprise sans court préavis du décompte.
So he says to stay ready for another imminent resumption of the countdown.
Yes.
This is the DDO Pierre Bardière, who's the dean of the DDOs, actually. I think this must be his 29th mission. And on his left is Philippe Roland, who we saw in the film, the mission director. He's from Arianespace, Bardière from CNES. This, I think, is Philippe Roland's 7th mission as a mission director. 6th or 7th. While we're waiting to pick up the countdown again, looking at what a launch base is, prepare the launcher and payloads, perform launching operations, and monitor the launch mission. Would you go along with that?
Go along with that. I would add that we've also the production of the cryogenic fluids, oxygen, nitrogen, and hydrogen.
That's unique to this base, isn't it?
This absolutely, yes. And also the solids from the solid boosters we are preparing here and manufacturing the two big segments of the boosters.
Which is not the case for Ariane 4.
Which was not the case for Ariane 4.
So when we say preparation of the launch vehicle, which means also reception and storage of the stages, because the stages come from Europe, right?
The stages come from Europe. The upper stage, for instance, the cryogenic upper stage of the ECA comes from Bremen, EADS Austria Bremen.
And we'll be hearing from the mayor of Bremen coming up, and we'll be hearing from EADS, so the people from EADS, I think, from Bremen as well, later on.
And the main cryogenic stage comes from Les Mureaux.
Outside Paris.
Of Paris. And the fairing comes from Swiss.
Contreves.
Zurich. Contreves. And everything is transported by boat, by one of the two boats which are assigned to the Arianespace business for transportation of launch vehicle, but also propellants for satellites and all the equipment that is necessary for the launch, so the upper stage and the main stage, and also the upper part elements.
Those come by boat from Europe?
Yes, the boat is going to Bremen, and then Les Mureaux, Le Havre, and then is departing from Le Havre to Kourou.
Crossing the Atlantic in what, 10 days?
It's about 10 to 12 days, depending on the weather conditions.
Now, the satellites don't come by boat usually because they're small enough to be, usually anyway, they're small enough to be put on a plane.
The satellite usually come by plane, but we may have to transport the satellite. It's more a matter of planning, of schedule, that they don't come by boat because it's 12 days in a planning. So they usually come by plane, but they could well come by boat.
You need a special plane? Do you need a special plane to carry satellites? Is there anything particular that you need?
Yes, so due to the huge dimensions of the satellites today, we need an Antonov plane.
It's a Russian.
Most of the time, the big Antonov plane to carry and flight the satellites from where they are to Kourou.
They come in big containers and.
They come in big containers.
Do they come with the adapters, or the adapters?
The adapter is part of the launch vehicle hardware, so this comes by boat.
So we're still waiting. We're stuck at 16 minutes. We're green, but not ticking.
I think we're about to resume.
We have a clear slate. We have
clear sky.
We have a clear sky. And when we get going, you'll see Ariane come roaring off the pad and will light up the late afternoon sky here. Always giving a good show to the people on the beach, on the beaches around the space base, and for those parked along the roads, and at the 6 or 7 observation sites. The Kourou base, geographically, the French government started building here in the 60s. And there's a couple of points that made Kourou the ideal site, because Kourou was one of, I think, 10 or 12.
À tous de l'EDO, attention pour la reprise du temps des comptes. Top! Reprise du temps des comptes.
Well, there we are. The DDO has called.
Nouveau H0 visé, 21h, 3 minutes, 1 seconde, temps universel.
All right, we're underway again. The new liftoff time at 21 hours, 3 minutes, and 1 second, the DDO has just said. So we are underway. We're still in our launch window. We have no problems there. So the problem was, as you said, with the helium or a...
I don't know exactly. It comes from the upper stage, upper cryogenic stage. There's some pressure transducers
That's right.
of the upper stage, and the measurements were wrong.
outside the normal.
or outside the specifications, and then they had to assess the consequences of either stopping the launch or continuing with fixing the problem.
So we've been holding for how long? We were holding for 20 minutes or more? Half an hour?
About 25 minutes.
25 minutes. So all is...
all is green now.
Green now. It's coming up on 14 minutes. The Ariane 5 ECA coming back into service after 26 months of an exhaustive review and rechecking of the engines, and a big moment for the European space community today with service of the big heavy launcher coming back. Good news for the customers. Good news for everyone.
Good news for everyone, and from the space community, and especially the European space community. And as you may have observed, that the flight directorate tonight is composed not only of senior management executives of Arianespace, but also CNES and ESA.
Now, is that particular to this flight?
Yeah, this flight is a qualification flight, for which the ESA CNES involvement has been tremendous, and it's also under the responsibility that this launch will take place tonight.
Because Arianespace will be taking over the commercial use of the vehicle in, I think, after 3 or 4 or 5 flights. I don't know exactly.
The next flight will be a commercial flight.
Next flight's a commercial flight. All right, tonight a qualification flight. You can see the green status panels, which is the color that we are happiest with. And what are the blue bars underneath there? Those are some other milestones that are down there. I think some of those are final arming of the satellite as we come down to -3 minutes.
Oh yeah, this is the last milestones are in the synchronized sequence, which are the main steps inside the synchronized sequence.
We mentioned we started to talk about the site here, and Kourou, the Kourou site in the 60s when the French government started building here. Was one of, I think, 10 or 12 possible launch bases. There were some in Australia, I think, and even north in Finland, I think, in Scandinavia, somewhere. South America, other parts of South America were considered. But France chose Guyana in 1964 to put the new base in. And there are a handful of good reasons why. The first is that there's a big opening, because we're right on the coast, there's a big opening so we can launch to the east, which is where telecom satellites go, which is where we're going tonight. And we can also launch north to a sun-synchronous orbit when we have that kind of a probe, which we did at the last launch, I believe.
We did the last launch with the Helios 2A, which was launched under which is owned by the French government, Ministry of Defense.
Military launch. And
also 6 other microsatellites, also for the Ministry of Defense, and one for the Spanish University.
So being able to launch over the ocean also is advantageous in the fact that when the stages are burnt out, they can drop back into the drink, and they're not dropping on anybody's house or anything. Which is also important. The proximity to the equator was also a big part of the decision to build the base here, because we are about 5 degrees north on the equator. Now, we take advantage of what they call the sling effect.
Well, we take advantage of the fact that the rotation of the Earth gives an initial velocity to the launch vehicle. That is energy, in fact. So you need less energy to launch at the same point in space. And on the equator, you'll need less energy than if you launch at the higher latitude
or lower latitudes.
Or lower latitude, yes.
So that's one of the big advantages here, because you actually have almost a direct line into space, taking advantage of the turning of the rotation of the Earth.
Almost a direct line.
Almost a direct line. Close enough.
Close enough.
So those two advantages. A third advantage in Kourou, very low density population in French Guiana. I think there's about 200,000 people here now, 91,000 square kilometers.
Yes, I think that the safety concerns are more and more something that is taken into account by governments and all the space industry.
Well, it's like the environment, like we saw.
Like we saw, yes, and this is quite a concern, and we have sometimes, and most of the times, to correct the trajectories in order to avoid to fly over highly dense inhabited countries.
In French Guiana, where you have 95% of the land covered by the Amazon forest, you have a pretty low population density, which is, of course, one of the other key elements in the decision to build a base here. A couple others, just briefly. No hurricanes.
No, we have, of course, a very stable wind.
Moderate wind effects, I would say.
Coming from the east.
Rarely,
and also the
rarely stronger than what 20 meters per second.
Per second. Oh yes, it's about the maximum that we experience here.
Although not far away, up in the French West Indies, they have they're hit by the hurricanes in the Caribbean.
Cyclones and hurricanes. It's true. Yes,
but not down here. So that was another reason.
That was, yes, that was the main reason too.
These, you can see right in the middle of your screen, the cryogenic feeder arms, the propellant arms, which are bringing the liquid hydrogen and oxygen into the upper stage. This is a split screen shot.
Yes, on the left side, you've got the oxygen plus helium feeding line, and on the right side, the hydrogen feeding line. So the principle, the concept is almost identical to Ariane 4.
And almost, again, identical to Ariane 4. When we have ignition, before we have liftoff, these arms that you see will retract. They'll pull back. On the Ariane 4, they swung open, left and the right. But those will pull back. You'll see this is the Vulcain engine, and you'll see that ignited. And then 7 seconds later, we'll have liftoff. We'll give you a detailed look at the actual ignition sequence in a moment. But just to finish off with the exceptional sight of at Kourou, we mentioned no hurricanes. There are also no earthquakes.
No earthquakes,
which you have in other parts of the world, of course.
À tous de l'EDO, attention pour H-7 minutes.
All right, now we're going to go into the final moments of final countdown. And we'll give you again, because I don't think we really covered it properly the first time around, the synchronized sequence. The synchronized sequence, you mentioned 2 computers, which are located in the Launch Operations Center, where we visited. And these computers are counting down the, I think there's 900 of them, 900 operations in the fluids and the electrical systems on the Ariane 5. So you can say that the computers are taking over.
Yes, the computers are taking over for the last operations to be performed before the ignition of the Vulcain 2 engine. And among these operations, of course, the end of the topping up sequence of the LOX and LH2 tanks of both cryogenic stages, but also the electrical systems are put into flight configuration, especially for the onboard computer, which will be monitoring the launch vehicle at H0 minus 22 seconds.
You said topping up?
I said topping up at the end of the high flow rate loading of the stages. We load with the lower flow rate in order to top up the liquid on top of the tank and get the most accurate level of boiling liquid, because those cryogenic fluids are boiling at this temperature and pressure.
Now you say boiling, but you think boiling and people think heat, but these are very low temperatures. That's the same thing.
Yes, I should have said that the hydrogen is at 20 Kelvin, 20 degrees Kelvin, which is minus 250 degrees Celsius. And the oxygen is at 90 degrees Kelvin, which is minus 180 degrees Celsius.
So at very low temperatures.
So very, very low temperatures.
You have a boiling off, just like you would if you had very high
We have a boiling off, and this is why we have to load at the end of the loading with very low flow rate in order to adjust and to have the most accurate level inside the cryogenic tanks.
Did you say low flow rate?
Yes.
The also, what is happening now? We talked about these two computers executing the final preparations of all these 900 operations. We said that there was one handling the electrical systems. This includes the initiation of the flight program, starting up of the motors, and safety control. And this one also, I believe, authorizes final arming of the more, what they call hazardous units, which includes, the pyrotechnic cords for separation, things like that, I imagine. For the different stages in flight. It also, this electrical computer will also load the exact ignition time into the onboard computer, which is done at minus 4 minutes and 30 seconds, which has already been done. The fluids computer is carrying out the flight configuration of fluids and the propellants. It will isolate the...
We'll isolate the cryogenic tanks and pressurate them at the flight pressure.
So that's flight pressurization, yeah. And then the same operation is carried out on the oxygen tank, I imagine.
Yes, absolutely, yes. Well, all LH2 and LOX tanks will be flight pressurized before liftoff.
And as we mentioned, these computers checking down all the hundreds of operations and will take us down to liftoff. And then the computers will also authorize the ignition of the motors.
Yes, during the synchronized sequence, at each stage, an operation has been done, let's say pressurization, then there is a monitoring of the values of the pressure temperatures. And then if it's correct, then the program continues for the next check.
And if not, we have...
And after each check, we have a possibility, if the control is not correct, to stop the synchronized sequence and return to safe configuration and come back to minus 16 minutes in that case.
So is this what happened when we had the hold before?
No, I think this would have happened if it had been during the a little bit later than when it happened actually in our case. But this is part of the synchronized sequence anyway, which is structured this way.
Because we were at 1 minute. We're very close to 0. 2 minutes now. You see Jupiter Mission Control is a shot looking down into the two parts of Jupiter Mission Control. In the foreground, the technicians and the people who make Ariane fly, from the European Space Agency, Arianespace, of course, the CNES, the Space Base, and the customers as well. Behind them, you can see the glass partition and people, the VIPs and invited guests, who are here to watch the launch, seated behind them in the red Jupiter Mission Control room. Again, the customer interface, your job?
My job, customer interface, and from the signature of the contract up to the launch.
One contact for the customer with Arianespace.
One single contact for the customer.
À tous de l'EDO, attention pour H0 moins 1 minute. H0 moins 1 minute et décompte.
All right, well, we're back where we were about half an hour ago. We're into the final 60 seconds of the final countdown. The people here at Jupiter Mission Control starting to wander out on the terraces here to get a shot. Can you, we promise now the ignition sequence. What's going to happen when the motors light up?
Well, at H0 we shall start the ignition of the Vulcain 2 engine, and during 7 seconds all the parameters of the propulsion system will be checked
By the computers, remember those computers?
By the computers, and if all the controls and all the checkouts are correct, then we shall go to the point of no return, that is ignition of the solids before liftoff.
And liftoff, we'll let you watch liftoff. The DDO will count off the final 10 seconds. We'll be back.
De DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Allumage Vulcain. Allumage des EAP, décollage.
Well, tremendous shots as Ariane rising into the late afternoon sky. Alex, you were mighty impressed. I don't know if you heard him at home there, but he was jumping up and down and banging on the table.
Yeah, so I have always been impressed by every launch I've participated to, and this one is one of the most impressive I've ever seen.
Ariane roaring off the pad into the beautiful early evening. And the sky is so clear, we're probably able...
Tous les paramètres bord sont normaux et la trajectoire est normale.
Trajectory and parameters aboard are normal, says the DDO. We'll for sure be able to see the booster cutoff and separation.
Separation from the core stage, yes.
And all the rest of the huge flames outpouring out the back of Ariane. That's 240 tons of solid fuel in each booster, and the 175 tons of fuel in the core cryogenic stage, all those burning at the moment. Each of those boosters, by the way, carries 90% of the thrust. We couldn't have liftoff without them, could we?
Now, of course, the boosters delivered the
Tous les paramètres bord sont normaux et la trajectoire est normale.
about 600 tons of thrust, and the Vulcain 2 engine about 136 tons.
Mass at liftoff of the Ariane 5 tonight, 780 tons, and she'll start to shed some of that weight. And coming up right about now will be the two boosters, which will drop, and we'll be able to see those on the camera. You'll see them fall away. That should be coming up in a second or two.
The DDO just said that
there we are.
Everything looking good.
Séparation des étages accélérateurs à poudre.
Separation of the booster, and you saw them, and there you can see they're going to fall back. And Ariane continuing, right in the middle, you see the single point of light there, and that's the single cryogenic stage, which is continuing to burn. As Ariane Flight 164 is well underway. The boosters, we'll talk about the boosters in a second, but before we do, we'll take a look at the curve. On the upper left-hand side of the screen, you have the cursor crawling up the line there. There are actually two superimposed lines. One is the ideal trajectory, one is the real-time trajectory. As long as they're one superimposed line on another, we're doing fine.
Yes, actually, it's a flight prediction. The flight prediction.
Séparation coiffe.
We just had the separation of the fairing.
We had separation of the fairing. The altitude of the separation is about 100 kilometers, which is approximately the altitude at which the White Knight, this famous aircraft, delivered the Spaceship One for a suborbital flight.
All right, that's
in October 2004. Remember that?
I do. You can see on the bottom left of your screen the letters A and V on the bottom. The A is the altitude, and as Alex said, we were just over 100 kilometers. Right now we're 135 kilometers. Our speed is 2.4 kilometers per second. That's about, well, how fast do we have to go to inject the satellite?
Well, at the end of the propulsion of the upper cryogenic stage will be at 9.3 kilometers per second.
So we have some ways to go. About 5 minutes left in the EPC burn. The EPC, the only propulsion now, will burn for 10 minutes. 6 minutes to go then.
A little bit less. It's 539.32 seconds. It's a little bit less than 10 minutes, but yes, it's the good order of magnitude.
All right, we are doing very well. Just a word on
Les paramètres bord sont normaux et la trajectoire est normale.
the word on the fairing. We have a medium fairing. The DDO has said when he calls out that everything is fine on board, the parameters and the trajectory. There's a medium fairing tonight.
Yes, there is
medium size, because there's 3 sizes.
There's 3 sizes: short, medium, and long. And we have medium fairing tonight. This flight configuration it will be the qualified flight configuration for Ariane 5 ECA. Then we can accommodate other configurations as demanded or required by our customers. But for the most of the standard flights, I would say, with the ECA will be this configuration.
We're going to go now to Bremen, the mayor, Mr. Sheriff, for a look at that town.
We here in Bremen, the people of Bremen, are looking to Kourou, looking to this launcher, and we all are behind this project. We wish them that this should be a great success for all of us, especially for Europe. We wish to show the world that we in Europe are able to bring researchers, scientists, everyone in the orbit, and that we are able to do it by our own. And I wish that we are able to be in a strong competition with the US colleagues. We wish to stay on our own, we wish to stay on our own project, and we wish to invite the whole world to do this with us. Happy launcher start on Friday. I am on your side.
The EADS people in Bremen also worked on the Vulcain engine. No, they didn't. We'll be back with that. We're over to Michael Caleri for a look at the satellite campaign. We'll be back. They didn't?
Il reste 2 minutes de propulsion au premier étage.
Tonight's Ariane 5 launch has 2 main co-passengers, the XTAR-EUR spacecraft for the American company XTAR, and the MAQSAT satellite. The MAQSAT satellite is a dummy spacecraft which simulates a true weight and dimensions of a standard communication satellite. MAQSAT is also equipped with SLOSHSAT, which is an experiment that will be released after separation and study the fluid dynamics in zero gravity. MAQSAT's campaign was slightly different than a normal communication satellite in that propellant loading was not required. However, a great deal of preparation was necessary for SLOSHSAT, the telemetry acquisition system in MAQSAT, and the video camera. The satellite, after all of that was checked out, the satellite moved to the bath to be mated onto the launcher and join XTAR and the launch vehicle in the combined operation. XTAR-EUR is a communication satellite that is in the X-band frequency and will be mainly used for military communications throughout the world. XTAR is the first launch for the American company XTAR, who's partners with Loral and Histosat. The XTAR campaign followed a standard launch operations campaign here in Kourou. After arrival of the satellite, electrical tests were done, followed by a helium leak test on the propulsion system. The satellite was then moved to the loading facility where the propellant was loaded on board XTAR. Following that, XTAR entered the combined operations with Arianespace, the launch vehicle, and MAQSAT.
Hi, your colleague Michael Caleri giving us a rundown on the satellite campaign. In just a few short seconds, we're going to come to the separation of the lower stage, the EPC as it's called, and the
extinction du premier étage.
Is the extinction of the lower stage. We're waiting for the separation of the lower stage and the ignition.
Séparation du premier étage.
Separation of the first stage, and we're waiting for ignition of the upper
allumage de l'étage supérieur.
And we've had those 3 commands, the EPC, the lower stage cutoff command, and the EPC jettison, and the upper stage ignition, 3 commands all taking place within 10 seconds, all ordered by the onboard computer. Now that we're into the second part of the mission, is it fair to say that the first half of the mission has been...
Les paramètres bord sont normaux et la trajectoire est normale.
We're, sorry about that. We are into the second stage of the mission, so it's fair to say the first part of the mission has been successfully completed?
Yes, not exactly. The almost half of the mission has been performed.
Almost half.
Yes, the rest of the mission is 942 seconds burning time for the upper stage.
How can you count in hundreds of seconds? Can't you just say minutes and like a normal person? This is hard for me.
No, this is just because we are used to use these units for counting and computing your trajectories.
Because then I have to divide by 60.
You have to divide by 60. That's right.
We'll be back with this math lesson. For now, we're going to Patrick Bonguet, Senior Vice President of Programs, on Arianespace's role in the ECA.
Today marks the return to flight status of the Ariane 5 ECA. What has been Arianespace's role here?
Well, the moment has finally come. The Ariane 5 ECA, which will become Arianespace's workhorse in the years to come, is about to fly again. 2 years have gone by since the Flight 517 failure. During this period, there have been many moments of doubt, introspection, self-criticism, and evaluation. We've seen independent review committees. I think that from a global point of view, the system has been considerably improved, not only in terms of technical and risk management, but also in terms of the launcher's robustness and reliability. These improvements have given us today a better launch system, especially as far as justification and representative testing are concerned, in particular with a fly-as-you-test, test-as-you-fly approach. So I can say that we've done what was needed to be successful in today's flight.
We'll be back with part 2 of that interview with Patrick Bonguet, Arianespace's VP for Programs, in about 8 minutes. But for now, Jean-Marie Luton was the former head of Arianespace, still chairman. The role of the ESCA, well, how would you describe that?
The role of the ESCA is to deliver the remaining thrust and energy to place the satellites on the proper orbit.
It adjusts the satellization of the payload so they can reach their proper orbit, right? Ensures also the right orientation for separation.
The right orientation for separation will be made, yes, by what we call the SCAR system, which are little thrusters.
Les paramètres bord sont normaux et la trajectoire est normale.
Trajectory and parameters on board, says the DDO, are normal.
Everything goes very good.
Everything is very good and green and go and
so these little thrusters are fed by the hydrogen pressure of the hydrogen tank.
Acquisition des télémesures lanceurs par la station télémesure de l'île d'Ascension.
The DDO's just said we've been picked up by our second downrange tracking station, which is on the island of the Ascension, in the middle of the Atlantic, which is a UK island, sending their data back here to Kourou. Ariane's flight is planned to be constantly monitored by the downrange stations tracking it. The first one is over the border in Natal. The first one is actually here in Kourou, behind us on the Montagne des Pères, and then the second one is over the border in Brazil at Natal and Ascension Island. And a little later on, we'll be getting the signal that the Ariane is being picked up by Libreville, which is in Gabon, west coast of Africa. And the final tracking station in the series is at Malindi, which is in Kenya. Continuing our visit of the Space Agency's role in the ECA, over to Michel Limard now of CNES.
Can you give us an idea of the CNES's role in the Ariane 5 ECA's return to flight?
The Ariane 5 ECA launcher is one of the most powerful in the world, and to make it operational, we have had to develop highly advanced and innovative technologies, sometimes even at the limit of our knowledge and know-how. The December 2002 failure was due to the Vulcain 2 engine, which was a new engine for Ariane 5. We had, of course, to correct the anomaly that we detected during the flight by reinforcing the nozzle extension which was at the origin of the failure. Then we had to qualify these changes. To do this, we carried out a comprehensive modification and qualification program which consisted of a series of engine tests and mechanical testing. In total, more than 20,000 seconds of testing were performed on the Vulcain 2 engine in extreme conditions which fully covered the engine flight conditions.
It's important to note that your work doesn't stop with today's launch.
Just after the launch, we shall have to perform an extremely important work by analyzing the measurements of the 1,400 sensors in the launcher in order to assess each of the different phases of the flight and verify that our flight predictions were correct.
We're at 200 kilometers up and almost 8 kilometers per second, approaching satellite injection speed. This is a qualification flight, which means what?
Qualification means that after the failure we had to re-qualify some parts of the launch vehicle, or to make complementary qualification of some part of the launch vehicle, so that we can ensure that everything was fine for this return to flight launcher of today.
The president of EADS Space Transportation now for our final visit on the EADS role in the return to flight status.
Under the responsibility of CNES and ESA, we did 3 major tasks. The first was to improve, together with our partners NECMA and Volvo, the Vulcain 2, in particular the nozzle and the cooling system, and also to set up a lot of vacuum tests with these engines. The second was to implement a lot of modification on the upper stage, ESCA, for example, additional vibration test and additional helium tank for special maneuverings and more margin on this stage. And third, to deliver a full qualification as industrial architect for the whole launcher 521, and this was possible and successful possible through a very, very engaged team, and all my thanks to the teams for this engaged improvements.
Back in Jupiter, 17 minutes into the flight, all is well on board. 8 kilometers per second. And the DDO keeps calling out that the trajectories are normal. You see in the upper left.
That means that the telemetry coming from the launch vehicle gives its position, and it fits exactly, matches exactly the flight prediction.
So we're on target.
Right on target.
About 6-7 minutes left in the ESCA burn. What is the difference in the propulsion between this new upper stage and the EPS, which is the Ariane 5 generic upper stage?
Well, the role of the stage is exactly the same, is to deliver the remaining thrust to get the proper orbit. Only this cryogenic stage is operated with LOX and LH2, that is oxygen and liquid hydrogen propellants, unless the EPS stage is operated with what we call storable propellants, that is...
Acquisition de la télémesure lanceur par la station de Libreville au Gabon.
The DDO is just called out, being received now by our third downrange station at Libreville, which we mentioned.
Nitrogen, tetroxide, and hydrogen, well, MMH, we'll call it MMH. So the thrust is different. The thrust is a lower thrust for the EPS and less energy at the end of the thrust phase for EPS than for ESC. This allows us to have heavier satellites on board the Ariane 5 launcher.
Part 2 now of our interview with Patrick Bongay, and we'll be back with more on Flight 164.
Tous les paramètres bord sont normaux et la trajectoire est normale.
What are the consequences of today's flight for the future?
Well, this afternoon's flight represents a new stage. It's a stage oriented toward the future, which consists of a set of 30 launchers called the PA batch. 25 of these are Ariane 5 ECAs, and their role is to guarantee the same excellence to which Arianespace owes its reputation. So the main challenge will be to guarantee the same quality performance or even improve it while keeping to the economic parameters of the PA batch business plan. Another key issue for tomorrow is preparation of the future, of new concepts and new technologies, which are essential if we want to progress and move forward. But also because in doing so, the quality service of engineering and development studies will provide Arianespace with fully reliable operational and commercial services.
Just to clear up any possible confusion, you may have heard in some of the interviews people talking about the ESCA and the ESC. What's the difference?
You don't need clarification, right?
I do.
So ESC is the upper cryogenic stage. A is simply the fact that it's the first of a kind, and with the HM7B engine on board. And ECA is the launcher, the launch vehicle itself.
We've also heard Flight 164 tonight, and also Flight 521, I think, was mentioned. Well, briefly, what's that?
Well, briefly, Flight 21 is more production batch number.
All right, we're going to give you some news on the XTAR satellite with their customer film, and we'll be back with more on our first passenger.
Hi, I'm Corey Westerhoff from XTAR, and we're delighted to be here in Kourou for this launch. And the first thing I'd really like to say today is a deep thanks to Hisdesat and all of our friends in Madrid, INTA, the Spanish Ministry of Defense. It's been a tremendous 6.5-year effort by everybody, and particularly our Spanish friends who have really made this launch a possibility today.
XTAR is a military and government communications satellite which will serve Spain and the United States. It's the first commercial satellite to deliver X-band services. It will be positioned at 29 degrees east, which will allow for coverage from the east coast of Brazil to Southeast Asia.
The launch campaign itself has been very long. SSL, Space Systems L'Oréal, has done a tremendous job. We started this campaign last October in the dry season, and right now it's coming to the end of the wet season. So it's been a very long campaign, and we're ready to go. Thanks goes to Arianespace, of course, for this launch. The launch itself is self-explanatory, and Arianespace doesn't need any accolades from us. It's pretty self-evident, and we look forward to many more years of future campaigns of this kind.
XTAR, as we mentioned, is a military and government communications satellite for Spain and the United States, carrying 12 X-band transponders. It's the first commercial satellite, they tell us, to deliver X-band services, built by SS L'Oréal, and the joint venture between SSL and Spain's Hisdesat company. The footprint will stretch, I think we saw it in the film, from the east coast of Brazil over to Southeast Asia. We want to say a word. 2 minutes of propulsion left in the upper stage.
Everything goes good?
Everything is very good. We will be picked up by our final tracking station at Malindi in a moment. We want to say a word now about someone special who's leaving Arianespace, if we may. Bertrand Lefebvre, who after 8 years of working on the video transmission, the one you're watching, is taking out to labor in another vineyard. And we're going to miss him, and we wish him well. And I just want to say, Alex, that
acquisition de la télémesure lanceur par la station de Malindi au Kenya.
All right, we've been picked up by Malindi. That's the final tracking station, which will see the extinction of the ESCA, operated by the University of Rome. Bertrand, I just want to say a word about Bertrand Lefebvre. I must say, Alex, of all the Arianespace people, that I've known over the years, I must say that Bertrand Lefebvre is, without a doubt, the one who I think eats the most French fries. Would you agree?
I have to agree, Josh. Yes, you're right.
All right, Bertrand. Bertrand, if you're listening, Get your hand out of the bag.
So the DDO call that the trajectory is perfect. There's still maybe less than 1 minute of propulsion.
24 minutes into the flight, coming up on extinction of the ECA. And then shortly afterward, we'll have separation, due to appear at about 26 minutes and 25 seconds of XTAR, the first passenger. Hear the DDO call out extinction of the ECA in just a moment. We want to say a word also about the 25th anniversary of Arianespace, which is this year. We had a
fin de la propulsion lanceur, extinction ESC.
All right, so there's the end of the propulsion phase, and we're into
Début d'orientation du composite.
The orientation phase. We'd like to get an explanation of that, but just before we do that, let me go to the quiz question first. All right? The moment you've been waiting for, the quiz question tonight, flight number 164. The question is, it's about MAQSAT. See if anybody can get this one. You know we're flying MAQSAT B2 tonight. It's not the first MAQSAT that Ariane has carried. Did you know that? How many others have we launched and when? Don't tell me now if you've got the answer. Save it. We'll be back with the answer in just a moment. But the quiz question number 164 is, tonight's MAQSAT's not the first. How many other MAQSATs has Ariane carried, and if you know when they were? Give you the answer in a minute. But for right now, what happens between the extinction of the ECA and the satellite separation? There's a whole series of maneuvers.
So this is the last phase of the flight, and we are in ballistic conditions. There is no acceleration from the launch vehicle. There is no thrust. So the satellite and the launch vehicle are only submitted to the Newtonian forces on the trajectory, and we have to orientate properly the satellite before releasing on its transfer orbit.
Which means you have to move it in one direction or another?
Yes, in order to orientate the axis of the main axis of the satellite as foreseen.
And there's another series of maneuvers in between the separations of the two satellites. We'll get back to those in a minute, and you can tell us about those. But it's mainly to make sure the satellite is going in the right direction and away from the composite.
Séparation XTAR-EUR.
Well, there's separation of XTAR, and it's an idea of what is happening up there. You notice there's no applause, but because people are being very polite and they're going to wait until the separation of the SLOSHSAT.
Réorientation du composite pour le largage du capot Silda.
So now we're reorientating what's left of the Ariane.
We're reorientating in order to first to avoid collision with the satellite that we have just released. So the rest of the composite will be reoriented, and then we have to deliver SLOSHSAT again in its proper orientation system.
That'll be coming up in about 4 minutes. But before then, we'll go to an interview with Jan Vreeburg of SLOSHSAT, and we'll be right back.
SLOSHSAT is a spacecraft for the study of sloshing liquids on board spacecraft. It is about the size of a washing machine, and inside it's not very much different from a washing machine because it has a big tank which is less than half full with pure water. If you are a truck driver, you would understand that it is difficult to steer a vehicle when there is liquid on board in a tank that is not completely full. If you want to make a corner or if you want to turn, then the liquid tends to proceed where it is going, and you have to move the vehicle around a bend. The same holds true for spacecraft, and in the past there have been difficulties with spacecraft or near difficulties with spacecraft. And that's why we like to study the behavior in order to be able to predict better what spacecraft are doing.
All right, apparently a relatively new subject of inquiry, this sloshing effect.
Sloshing effect, yes. The sloshing effect of the liquid inside the vessels, inside the tanks, in fact, in propellant tanks of satellites, is already taken into account in our computations.
Séparation du capot Silda.
Separation of the Silda.
We have separation of the Silda right
what's
now.
the Silda?
The soldat is the carrying structure which allows Ariane to be able to perform double launches. So this structure carries the upper satellite on top, and in its inner volume, it envelopes the lower satellite.
All right, give you the answer to the quiz question. Any of you think you got the answer? How many other MAQSATs and when were they launched? Did you come up with anything?
I remember 502 was one of the launches where we had a MAQSAT.
502, otherwise known as Flight 101, a qualification flight for Ariane, October of '97. MAQSAT H, MAQSAT B, built by Kaiser Threde. Right? There are other mock-up simulating satellites is basically what they are. But there was another one. You're only half right. No? You don't know? Flight 503, 112, Flight 112 in October of '98 with the first ARD.
With the first ARD, yes, you're right.
I know I'm right. I got this out of my book. MAQSAT 3, which was not separated, just like tonight.
Yeah, just like tonight. So the MAQSAT...
L'orientation du composite se poursuit normalement.
The orientation is performing well. Everything looks good. So the MAQSAT will not be separated from the ESC, but only the little SLOSHSAT, 130 kilos satellite, will be separated from MAQSAT itself.
MAQSAT, again, it's a model which will measure the internal environment of the Ariane 5 during the mission.
Yes, they move the motion of fluids inside the propellant tanks in microgravity.
It's also going to carry images from the cameras, right?
The cameras are attached to the VEB of the remaining composite here, upper composite. One is external. It has filmed the launcher's environment during the liftoff and during the first phase of the flight.
Fin d'orientation du composite.
Especially the separation of the booster, and the other one is internal. It will film the separation of the upper structures and the satellites.
First time in many years that we've had onboard cameras. And hopefully we'll be able to use those images.
Les mesures du satellite XTAR ont été acquis par la station de Assad en Inde.
So the XTAR has been, telemetry has been acquired by the Indian station of Hassan.
That's their first...
Séparation SLOSHSAT.
SLOSHSAT has been separated. And this is the end of the mission for Ariane. It's not really the end of the flight. We'll come back later to that. Let's have a look at these happy faces.
Happy faces, champagne coming up, cigars, T-shirts, all the rest of it is Arianespace once again delivering for the first ECA. I'm still confused.
The first ECA launcher.
First ECA launcher. We're going to go to the speeches now, the traditional post launch speeches. We may have a replay. We may have a couple of replays of the launch for you from different cameras. As soon as we get the word, then we'll tell you which one. There's one from Vulcain, which is closest to the launch zone, and there may be some others. And then after that, we'll get the speeches. Jean-Yves Le Gall will be speaking. Jean-Jacques Dordain, probably from ESA, the CNES chairman, and others. So while we're waiting,
de felicitaciones de los responsables de Arianespace y de los clientes. Es en imágenes también el director de operaciones.
Coming up with our first replay now, so we can let you watch those wonderful shots that so moved Alex.
7, 6, 5, 4, 3, 2, unité, feu. Allumage Vulcain. Allumage des EAP, décollage.
Jean-Yves Le Gall is ready for the first of the speeches.
Eh bien, comme vous l'avez vu, Ariane 5 vient de réussir son retour en vol, effaçant ainsi l'échec de décembre 2002. Ce succès nous l'attendions tous et je voudrais remercier tous ceux qui ont contribué. D'abord, les États membres de l'Agence spatiale européenne qui avaient décidé, quelque temps après l'échec de décembre 2002, de trouver les moyens de financer ce retour en vol. C'était difficile, il y a eu des débats. Ceux qui croyaient en Ariane 5 l'ont emporté et ce soir, il est clair qu'ils ont eu raison. Ensuite, je voudrais aussi remercier tous les ingénieurs et les techniciens de toute l'Europe spatiale qui ont travaillé sans discontinuer pendant des jours et des nuits pour nous donner le succès de ce soir. Et je crois qu'on peut dire que jamais personne n'a baissé les bras, jamais les gens ne se sont découragés et toujours on a su trouver les bonnes solutions. Et le succès de ce soir montre à quel point ceci était bien ordonné. Enfin, je voudrais aussi remercier les clients d'Arianespace qui ont continué à nous faire confiance. Tout d'abord, la société XTAR, et tout à l'heure je serais très heureux que la présidente d'XTAR puisse s'adresser à nous, mais la société XTAR qui a accepté que son satellite soit lancé ce soir. Elle a eu raison, la mise en orbite parfaite à laquelle nous avons assisté l'a amplement démontré. Mais je voudrais aussi remercier tous les propriétaires et les promoteurs des 18 satellites qui nous ont fait confiance depuis l'échec de décembre 2002. D'ailleurs, ce soir, il y en aura un 19e parce que nous venons de signer un contrat, un nouveau contrat. Et tout cela nous ont fait confiance pendant tout ce temps et ils ont été à nos côtés. Et je voudrais vraiment les en remercier. Alors à tous qui nous regardez en ce moment exceptionnel, eh bien, je voudrais vous dire bravo et merci. Et sans plus tarder, je passe la parole à M. Dordain, directeur général de l'ESA. Merci.
Bonsoir. Je dois dire, à partir d'aujourd'hui,
As of today,
nous retournons vers le futur.
we are heading back to the future.
On vient de franchir une étape
We have just
importante.
gone over a major
Moins d'un mois après s'être
milestone.
posé à la surface de Titan.
Little under a month after reaching the surface of Titan, and this was indeed a titanic task, which we have made a success. It's a new proof of the expertise that we have in Europe, and I would this evening very much, from the bottom of my heart, like to thank all of those who have contributed to this success. First of all, industry, all of the industries involved, all of the member states of the European Space Agency, in which that industry is to be found. CNES, and particularly its launcher directorate, which has been working so hard over the last 2 years. My thanks also to Arianespace and also to my colleagues from ESA. We have asked much of everybody involved, and they have managed to do what was asked of them. Indeed, it has been quite remarkable to see how they reacted. I'd also like to thank all of the member states of ESA. I'd like to thank them for their support, as Jean-Yves has already said, and also for their patience. We were keen to get the return to flight a reality as quickly as possible, but what was more important was to make it a success, and we have done so. It took us 2 years. That's the time that's necessary to have a return to flight of a launch vehicle such as this. I'm thinking of our Japanese colleagues, our American colleagues, who have also worked for 2 years for the return to flight of H2A and the shuttle that will refly in a few weeks' time. This is something that is due to come about, and I wish them as much success as we have enjoyed this evening. We are now going to be able to look to the future, devote ourselves to the future. In the short term, we have a number of missions for launches in 2005. We have a new ESA satellite in orbit, SLOSHSAT. But there are others as well. There's going to be a cryosat launch. That's the first in the Earth Explorer series. These are satellites that are going to study the evolution of polar ice. And then we'll have Meteosat second generation to be launched by Ariane 5 later this year. Venus Express as well. And also the first Galileo spacecraft. And we have our colleagues Vittoria and Reiter that are going to be going up to the International Space Station. We've been preparing new programs, GMES, exploration, and at the end of this year, major decisions will be taken in that context by a council of the agency meeting at ministerial level. We're looking to the future of the European space sector. Today has been a success, that is true, but we must consolidate it further. Otherwise, nothing will be really possible in Europe. Ariane, over the last 20 years, has become a symbol of a Europe that wins when it joins forces. Sometimes it's difficult to be a symbol because you're not forgiven the slightest mistake. But it's a symbol that can mobilize people. It can push back frontiers between countries, between different parties, agencies, operators, industry. It is a truly European symbol that is known well beyond the borders of our continent. Well done, Ariane, and thank you, and well done to everybody involved.
Bien, bonsoir, mesdames et messieurs.
Ladies and gentlemen, good evening. My voice is a little bit shaky this evening. I think I'm probably not the only one to feel fairly moved, but I'm certainly very happy this evening to be able to share with you this tremendous success. I think we can all be proud that the Ariane family has just grown with a new arrival, Ariane 5 ECA. I would really very much like to express my gratitude and congratulations, first of all, to ESA and all of its member states and the French government. I thank them for placing their trust in Ariane. Ariane can now guarantee access to space for Europe. I'd also like to thank the customers, XTAR, Hisdesat and L'Oral, for their having placed their trust in us. My thanks and congratulations to everyone working at the Guyana Space Center, the CSG, where we are this evening, who have worked so hard to contribute to this tremendous success. And I'd very much like to thank, in particular, those who work for the CNES Launcher Directorate, the DLA, and I would like to pay a tribute to their tremendous contribution that has been so important in this successful qualification flight of Ariane 5 ECA. Many of us here this evening know how much we owe to them in this success. Let us pay them a tribute. I'd also like to thank and warmly congratulate all of those from Arianespace and from our industrial partners, because it's important for everybody to realize that all members of the European team have enjoyed this joint success. Let me finish by saying we must show humility. That is true of any engineer facing up to the challenges of science and technology and pushing back the further frontiers of knowledge. So, as of tomorrow, perhaps even this evening, we'll start immediately drawing lessons from this qualification flight and preparing the future. Thank you very much once again, and enjoy the evening.
Bonsoir.
Good evening.
Mi más sincera felicitación a Arianespace por el éxito del lanzamiento que
My
acabamos de
most
presenciar.
sincere congratulations go to Arianespace for this successful launch. I'd also like to pay tribute to all of those who, for such a long time, have been working towards the success of this project and who have participated in this historic flight, which will mark the opening of a new era. It's a job well done. As Europeans, we can truly be proud of our technological capacity. I would like to congratulate the European Space Agency and CNES, the National Centre for Space Studies, for the very long and hard work that has been carried out over the last years. I think that the success of this evening is a true reward for that effort. The European space transportation industry, which is represented here by many of you, in particular EADS as the prime contractor, is an industry that can truly be satisfied at the success of this project. And I think that this project, this success, is going to contribute to the prestige and image of this international industry. I'd also like to make a special mention of the extraordinary participation of Spanish industry led by EADS CASA Space, which played a major role in the launch's upper structure. This program would not have been possible without the enthusiastic participation of the XTAR and HISTASAT team, and also the satellite's manufacturer, Space System Loral. We've also had the participation of the Spanish Ministry of Defense. Thank you all for your efforts and commitment to this project. There's also been a very significant contribution made by Spain's space industry in the development and manufacturing of the satellite. There's no denying that the elements provided are of extraordinary technological value for the communications payload. I'd like to refer to EADS CASA Space, which developed the parabolic reflectors, the feeder horns and X-band. Then we have CNR, that was for the positioning and hold-down mechanisms of the antennas. RIMSA, telemetry and telecommand in S-band, and also the filters, couplers, hybrids and waveguides in X-band. INSA is responsible for the ground antennas of the satellite's telemetry, and also commands in X and S bands. Indraspace, EADS, CRISA and GMV have also carried out a whole series of projects for the program. The total coverage that comes thanks to the satellite and the system will cover pretty much 2/3 of the Earth's surface, from Singapore to the west of Denver. It'll mean that the industry and the Spanish Ministry of Defense, and also a number of other governmental organizations of allied countries, will be able to benefit from everything that can be offered by this project. And this will constitute a major improvement of their communications capacity, whether we're talking about it from the point of view of power, bandwidth, coverage, or security. The current capacity will be multiplied by a factor of 3. There are a large number of steerable antennas and beams. They're interconnected, which means that the system will have greater flexibility so as to provide an immediate response to different government needs. There's another element worth noting, and that is the high level of security in access control of these satellites. Here we're talking about low vulnerability in encrypted algorithm of the command. And also the system is interoperable with all of the existing X-band ground terminals, which is very good in terms of compatibility with systems in other allied countries. And it's really now that our work is going to begin. Our goal is to offer a high-value communication solution for X-band, and particularly from the point of view of its strategic import. The program was conceived to satisfy the operational requirements of the Spanish Ministry of Defense, which has backed the project right from the start. We have an ideal system now to respond to the Ministry's communication needs, due as much to its security as its flexibility. We expect much of our XTAR colleagues today, and we have high hopes for the sort of acceptance that the project will receive from our friends in allied countries. This is our mission. We will continue henceforth for foreign policy, security and defense, and continue to provide technological answers. Thank you very much.
First, I want to thank the Arianespace team for a terrific launch. It is really great to see the ECA is back on track, and I'm glad we were there for the ride. A very sincere and warm thank you to XTAR's 2 main partners in this venture, Loral and HISTASAT, who've really supported XTAR really when the going was tough. They really brought this venture to fruition along with us. Thanks to the members of Spanish industry that played such a critical role in the project's development, and especially to the Spanish Ministry of Defense for their support, and as our first customer on XTAR. We're looking forward to beginning that service shortly. This launch is a culmination of many years of work among our partners in Spain, as well as SSL and Loral Skynet. I want to thank, in particular, number of companies, INTA, INSA, INDRA, and Hispasat for their work on the ground stations, and to Hispasat for their support in the ground frequency coordination effort, and to CASA EADS, SENAIR, and RIMSA for their support on the satellite. And of course, I have to thank for the tremendous effort that they performed on the satellite, the great team at SSL. I also want to thank the team at Skynet for their support to XTAR in so many areas. Finally, my thanks to the small XTAR team in the US and Madrid for their dedicated support over the last 4 years, and in some cases more than that. It has been truly a cooperative effort among a lot of people in a lot of countries. XTAR is a unique business, and we believe a superb way to bring much-needed X-band services to all branches of the military. XTAR is an opportunity that will give the US and allied military really everything that they've been looking for in terms of satellite communications. Global beams and steerable beams that can be moved within the satellite's tremendous coverage area, an area that stretches from eastern Brazil across the Atlantic to all of Europe, Africa, and the Middle East, out to Singapore and Southeast Asia. The capacity is compatible with all of the military legacy Earth terminals in existence now, and it is very high power, which means it can be used with very small terminals, including manpacks. XTAR is now there to provide capacity in support of the discus and wideband gap filler systems in the United States and beyond. With SpainSat entering service next, a truly unique network of X-band satellites will be ready to serve the US, Spanish, and allied governments. Thank you. Thank you very much.
Mesdames, Messieurs, chers amis, je crois que nous sommes tous très, très heureux.
Let me say how delighted we are this evening. Well done to everybody in Kourou and to everybody here as well. This is a tremendous contribution that you have made to the success of Space Europe, to the success of Arianespace, to the success of Ariane 5 ECA. We're all proud, we're all happy to have witnessed this tremendous success, which was a veritable challenge. It is a veritable success for the entire space community of Europe. That means primarily all of the men and women who have contributed so much in making sure that the return to flight program worked. Without their hard work, without their devotion, this evening's success would not have been possible. As the Minister for Space, I would very much like to thank the CNES and obviously its President, Mr. Descata, and thank you in particular to everybody working in the DLA. You have played a vital role in this success. You played the major role in the verifications and diagnosis work that has then led to further steps taking us up to this evening. The entire space community deserves our thanks. I'd also like to thank Jean-Jacques Dordain from the European Space Agency, Jean-Yves Le Gall, Arianespace, who now has probably a tremendous feeling of relief, as many of us do. In fact, we share this feeling. So well done, one and all. Congratulations to everyone working with you. Congratulations to industry, EADS, Mr. Camus, Mr. Oak, Congratulations to SNECMA. The real issue here was the engines. Vulcain works well. It hasn't been working often lately, but we're convinced now that it is totally reliable. We have seen its excellent performance. And I would say that all of this means that we're probably up among the space leaders of our age. This success has particularly symbolic value as well. It's a question of sovereignty, after all. A launch capability is a vital instrument for European governments. It'll give them guaranteed access to space, and it will give them full independence as regards the sort of information they need for political reasons, economic reasons, and scientific reasons. Such an instrument must be guaranteed over time. We can see that the member states of ESA have placed their trust in Ariane for the long term, and for this I'd like to thank them. Ariane is the cornerstone of space future for Europe. We must now look to the future and continue to turn the pages of this book that we opened so many years ago. We have also to thank the customers for having placed their trust in Arianespace. But we are facing many challenges in the future. And the success will depend on the competence and creativity of all parties involved. Ariane is a powerful symbol for Europe, not only for science and research, but for our citizens. And it reconciles us with the progress that can and should be made by science. Aside from the strategic import and the economic aspects, space is one of the most visible and credible indicators of cohesion in Europe. With joint effort on the part of its member states, continued cooperation are decisive in the context of European construction. And this confirms that we must continue along the same path. I have to say that I'm proud to be a European this evening. I'm convinced that the Europe we have seen this evening is the Europe of the future.
Jean-Yves Le Gall will say some closing words, and then we'll be back to say goodbye.
Bien. Merci, Monsieur le Ministre, pour ces paroles extrêmement encourageantes. Juste un point avant de nous quitter ce soir. Donc, les ingénieurs et les techniciens qui ont travaillé pour le succès de ce soir ont demandé que ce succès soit dédié à la mémoire du professeur Curien qui nous a quittés ces derniers jours et qui a joué un grand rôle dans l'histoire d'Ariane. Donc je crois que nous pouvons le faire avec beaucoup de plaisir et d'émotion. Donc dédier le succès du lancement Ariane 5 ECA à la mémoire du professeur Curien. Et par ailleurs, donc, nous avons, vous le savez, un programme 2005 extrêmement chargé, avec un objectif de 6 lancements, y compris celui de ce soir. Donc rendez-vous pour le prochain lancement, ici, le 14 avril. Voilà, merci, bonsoir.
We're going to go to a final replay and we'll be back to say goodbye.
6, 5, 4, 3, 2, unité, feu. Allumage Vulcain. Allumage des EAP, décollage.
apparemment les EAP sont se barrer, c'est pas trop tôt.